Hi everyone. In this session, we are going to discuss about the characteristics of sound. Okay. So we know that there are some characteristics properties which will make us to identify two different sound. Okay. Let us see which are those characteristics. So first one, loudness. Second one, pitch, or we can call it as shrillness. And the third property or third characteristics, that is called quality or timbre. Okay, so these are the three characteristics property which will help us to distinguish two different sound. Now we'll see this in detail. All these qualities, loudness, pitch and timbre or quality, can be studied when we connect the microphone or the loudspeaker to a CRO. CRO means cathode ray oscilloscope. It is a kind of screen which displays the displacement time graph of a sound wave. Okay, whichever the output we are giving, input we are giving, it will show it as in the form of a wave. Okay, so first let us see about loudness. What is loudness? It is a characteristic property of a sound wave which help us to identify the loud note from a faint note. Okay, loud note from a faint note. Okay, for example, just consider we have a tuning fork. Okay, loudness means that for that particular characteristic property, the quality and frequency will be constant. Constant in the sense that will be same. Okay. The frequency won't be changed and even the quality. Only the loudness will vary for the particular sound. For example, just consider a tuning fork. So we know that tuning fork means it is of monotone. Monotone means single frequency. Okay. So just strike the tuning fork on a rubber pad. It produces sound. Just consider that it produces a faint sound. Okay. And another time, hit it very hardly, so you can hear a loud note. Okay, so in that condition also we are not changing the tuning fork, only the movement, we just hit it harder. So because of that, which quality changes? Loudness. So loudness is always depends upon the amplitude. Okay, so we can represent that in the form of a displacement time graph. Just consider this is a displacement time graph. This is time and this is displacement. Okay, so first condition, we got a graph like this way, a repeated one. Okay, so same way, this is the first one, soft note, or we can call it as faint note. Okay, next one, frequency is not varying, exactly same frequency, but only the amplitude is increasing. Okay, as we hit it harder, the amplitude got varied. Same way, it's a time displacement graph. Okay, so time displacement graph. So this is a way how we can represent the loudness. So simply we can tell that amplitude is a factor which depends upon the loudness. Okay, amplitude is a factor which depends upon the loudness. When you hit it harder, what happens? More energy is produced and that energy made it to vibrate with a larger amplitude. Okay, so actually loudness and intensity of sound wave. Sometimes we may get confused or we may feel that both are same, but actually it is related, but we can't tell that intensity or loudness is always equal to intensity. Let us see how it varies. So intensity means it is the amount of sound energy passing per second through a medium per unit area. Okay, intensity of sound wave at a point means it is a sound energy passing per second normally through a unit area. Okay, so for a particular unit area, how much energy passed per second, that will give us the intensity. And it's always represented with a unit watt per meter square. Okay, watt per meter square. For a normal sound, the range can be 10 to the power minus 6 watt per meter square. It is a normal sound. Okay. The minimum level of intensity of sound is always 10 to the power minus 12 watt per meter square. This is a normal sound and this is a minimum sound. Minimum sound intensity. Okay, minimum sound intensity is 10 to the power minus 12 watt per meter square and this is a normal sound intensity. Okay. And the intensity of sound depends upon few factors. Okay, as the greater energy is passing through a particular point or unit area, we can tell that that particular sound has more intensity. If less amount of sound energy is passing through a unit area, we can tell that it is having less intensity. And the intensity depends upon different factors. Okay, we'll see which are the factors depends upon. Intensity is proportional to the square of the amplitude. It is proportional to the square of the frequency. It is proportional to the density of the medium. Density of the medium. And it is proportional to the speed of sound. Okay. Or we can tell that it is D and this is V. Okay. So these are the four factors which is depends upon the intensity. It is directly proportional to the square of the amplitude. It is directly proportional to the frequency of the amplitude. It is directly proportional to the density of the medium. And it is directly proportional to the speed or velocity. Okay. Or velocity of sound. Now, we can tell that always loudness is subjective in nature and intensity is objective in nature. What is meant by subjectivity and objectivity? Objective things means whoever measure, the value will be same. But subjectivity means, for example, you are writing some essay. Okay, for English paper, you may be writing, there was a question comes like, write an experience related with something. Okay, the way how children write, it always depends, right? No? So, the teacher can't expect same answer from anyone. You'll be individual differences are there, so you'll be writing in your own way. So that quality we used to call it as subjectivity. So depends upon individual person, the explanation will vary. But if it is a multiple choice question, okay, so you are getting whichever the subject, you are getting a multiple choice question. Okay, so always for that condition you will get a single answer. Right answer means there will be a single answer. So there is an objectivity. Whoever write the right answer, whoever correct your paper, there won't be any variation for the particular mark. Okay, that is called subjectivity and objectivity. Let us see how subjectivity and objectivity is related with. First one we'll see loudness. Okay, loudness is subjective in nature. It is subjective in nature. We'll see how it is. So we can tell that loudness depends upon the energy because sound is a form of energy. So depends upon the energy, the loudness may vary. Okay, loudness is always depends upon the intensity. Okay. So intensity means it is the amount of energy convert near to our eardrum. Okay, so likewise we can, because intensity is a factor which is related with the energy. Second one, it is a sensitivity of the listener. Sensitivity of the listener. So each and everyone have their own individual differences with the sensitivity. So some people, if we hear the same sound, they may feel that it is very louder. Some people may feel that it is a very faint one or a normal one. Okay. Moreover, it will depends upon the distance between the source and the listener. So for smaller ones, for example, a DJ music. Okay. A DJ music. For the youngsters, we never feel that it is like a loud sound or a very feeble sound for us, or we may not consider it as a noise. But for some old people, they can't bear that sound. So there comes the sensitivity of the listener. So loudness, so some people feel that it is very louder, some people feel that it is not that much louder. So there it depends upon the intensity, how much energy is passing. At the same time, it depends upon the sensitivity. Some people with the same intensity sound, some people may feel that it is louder and others will feel that it is not louder. So because of that, we can tell that there is a subjective nature. According to the individual difference, there will be a subjective nature for loudness. But when we come to the case of intensity, okay, purely the intensity, it is completely related with the energy, sound energy, the amount of energy carried by the sound wave from the source. Okay, it's the amount of energy carried by the sound wave from the source. So wherever we measure the energy passing through a unit area, we will get the value. Or we can tell that it is a measurable quantity. It is a measurable quantity. So loudness is not a measurable quantity. It may vary, depends upon the person and the amount of sound energy reaches the eardrum. But here intensity is purely depends upon the sound energy passing per unit area, and it is a measurable quantity. So it is objective in nature and loudness is subjective in nature. The sensitivity of ear for a person is maximum at 1 kilohertz frequency. Okay, if the frequency is 1 kilohertz, we can tell that that is a maximum sensitivity level for a person. Now let us see which are the factors depends upon the loudness of a sound wave. There are mainly 5 factors which depends upon the loudness. First one, amplitude. Okay, first one, amplitude. The loudness is directly proportional to the square of the amplitude of the sound wave. As the amplitude increases, what happens? It sends with the maximum energy will make the object to vibrate very fastly. Okay, so as the amplitude increases, the energy spent to vibrate to and fro will be more. So automatically we can hear a loud note. Second one, it is the distance between the source to the listener. Okay, so distance between the source to listener. So here loudness is inversely proportional to the square of the distance from the source to the listener. For example, one person is very close near to the loudspeaker. For him, he feels that it's very louder sound, and another one is sitting at the back side of the auditorium. So there's a more distance from the source to that second person. So for him, he will feel that it's a normal sound or a faint sound. Okay, so depends upon the distance from the source to the listener. The loudness is directly proportional to the or inversely proportional to the square of the distance. And the third one is area of the vibrating body or surface area of vibrating body. Okay, so here as the area of the vibrating body increases, it sends forth maximum energy. So as the energy is sending forth maximum, we can hear a loud sound. Okay, for example, just take a tuning fork, hit it hard against the rubber part, so you can hear a sound. Then do the next time. After hitting on the rubber part, just keep it on a tabletop. Comparing with the tuning fork or the rubber part, the area of cross section is less. When you keep the tuning fork, the vibrating tuning fork on the table, the area of the table is very high, so it sends for the maximum louder sound. Okay, that is our third point. Our fourth point is density of air or density of the medium. As the density of the medium increases, the loudness also increases. And the fifth point is the presence of resonant object. Okay, presence of resonant bodies. We know that if the resonant bodies or the equal frequency bodies are there, obviously both will vibrate with a larger sound. The second body start vibrating with a larger amplitude, and obviously it produces louder sound. So these are the 5 factors which depends upon loudness. Amplitude directly proportional to the square of the amplitude. Loudness is inversely proportional to the square of the distance from the source. Then it directly proportional to the surface area. As the surface area is maximum, we will get maximum louder sound. Then same way it's directly proportional to the density, and even the presence of resonant body also will give us a louder sound. Now let us see the relationship between loudness and intensity. We know that loudness depends upon intensity, but we can't tell that loudness is always equal to intensity. As intensity varies, automatically loudness also has some variation, but it's not in a direct proportion. Okay, two scientists called Weber and Fresner, they have stated a relationship between loudness and intensity, and this is the relationship. L is equal to K log 10 I. Okay, so I is the intensity, L is the loudness, K is a proportionality constant, and L is a logarithm with base 10. Okay, so this is a relationship between loudness and intensity. Now let us see what are the unit of loudness. Okay, so the loudness is always represented by a unit called phone. It's called phone, F-P-H-O-N, phone. Okay, and this loudness, the phone is always a measure of sensation. It's a sensation of hearing. Okay, so phone represents the sensation of hearing, and the level of sound. Okay, level of sound is measured in terms of decibel, or small d capital B, decibel. Decibel is a unit of level of sound, and the unit of loudness is phone. Unit of loudness is phone, and the unit of level of sound is decibel. When the sound is vibrating with a frequency 1 kilohertz, when the sensitivity of the frequency is 1 kilohertz, at that time this phone will be equal to dB. Okay, phone will be equal to dB when the frequency is equal to 1 kilohertz. When the sensitivity of the frequency is equal to 1 kilohertz, only during that particular condition the value of phone will be equal to decibel. But just consider that at a particular frequency, two sound produces with two intensity. Okay, I'm going to write it as L1 is equal to K log 10 I1, and another sound with intensity L0 is equal to K log 10 I0. Okay, consider this 1 and these are 2. So same frequency, but it produces two intensities with two loudness. Now we'll find out the difference. Okay, so L1 minus L0 is equal to K log 10 I1 minus log 10 I0. Okay, actually this is a mathematical relationship. Log 10, log to the base 10 A minus log to the base 10 B is equal to, we can write it as log 10 A by B. This is a mathematical relationship. Same relationship we are going to substitute here. Okay, so we can write it as K log 10 I1 by I0. So it's common L. The loudness, difference in loudness is equal to K into log 10 I1 by I0. Consider if I0 is a minimum sound level, that is 10 to the power minus 12 watt per meter square. Consider I0 is the minimum sound level with a frequency 1 kilohertz. we can consider L as the sound level. Okay, if I0 is a minimum intensity level at a frequency 1 kilohertz, this L we can consider it as a sound level. Okay, so in that condition, if we take K is equal to 1, we are going to take K as 1. Okay, the constant as 1. Then we can write this equation as L is equal to log I1 by I0 bell. Because sound level, the unit is bell. Okay, so we studied the level of sound, the unit is decibel. Then from where this bell has come? Actually, bell is equal to 1 by 10th of decibel. Okay, I'm going to rewrite it as 10 log I1 by I0 into 1 by 10 bell, that is equal to 10 log I1 by I0 decibel. Okay, so in mathematics you will study how to find out the value of log and anti-log. Just consider the case when I1 is equal to I0, we are going to get L is equal to 10 log 1. Actually the value of log 1 is 0. We will get loudness is equal to 0 dB. That means when the sensitivity level is 10 to the power minus 12 watt per meter square with a frequency 1 kilohertz, the loudness is 0 dB. The minimum loudness level is 0 dB. So the minimum sound of intensity, the loudness level is equal to 0 dB. Now we just consider that you are going to increase this value. I1 to 100 I0. After substituting, you will get L is equal to 20 dB. If it is 100 I0, after substituting the value, you will get it as 20 dB. If you are increasing I1 to 10,000 I0, you will get the value of loudness is equal to 40 dB. Likewise, the intensity and the loudness will vary. Okay. For minimum sensitivity of sound, L is equal to 0 dB with a condition I1 is equal to I0. Just consider that we got L is equal to 1 dB. Then how this intensity varies? Okay, when intensity is equal, we will get loudness is equal to 0 dB. If the loudness increases to 1 dB, how intensity varies? Okay, for that actually we are writing 1 is equal to 10 log I1 by I0, or we can write I1 by I0 is equal to anti-log of 1 by 10. So after substitution we will get 1.26. Or we can tell that when loudness is increased by 1 dB, the sensitivity of the sound is or intensity of the sound is increased by 26%. Okay, if the loudness increased by 1 dB, the intensity of the sound will be increased by 26%. So this is the way L is equal to K into log I1 by I0, or I, simply I. That is the relationship how loudness and intensity depends. It varies, not in a proportional way. We are very familiar with the word noise. Teachers always, when they come to your classroom, they always used to tell that don't make noise, right? No? What is meant by that? It is also a thing which is related to the sound. Okay. So any disturbance produced by any kind of source, any disturbance in the sense any kind of sound wave produced by any kind of source, and if the sound level is above 120 dB, we used to consider it as noise. Okay, the sound produced by loudspeaker, the vehicle horn, anything, any sound which is having the loudness above 120 dB, we used to call it as noise. If we are being continuously under this noise or loudness above 120 dB, It can cause some headache, some people may have the heart attack if they have any issues with the they are undergoing with any heart issues, or some people even it can cause even mental disturbance. Okay, so the sound level which is above 120 dB or the loudness level above 120 dB, we always used to consider it as noise. Okay, the safe limit of sound level is always 0 dB to 80 dB. 0 dB to 80 dB is known as the safe limit. This is called the safe limit of sound, and we have a soothing limit. 30 dB to 10 dB is known as soothing limit. Okay, it's called as soothing limit. And the limit of hearing. Okay, the limit of hearing, that is 0 dB. The limit of hearing in the sense that is a least limit what a human here can hear. Okay, so 0 dB is a least level of loudness that a human ear can perceive. That is called the limit of hearing. And don't get confused with the limit of hearing and audible range. Audible range is always expressed in terms of frequency. What is our audible range? It is 20 Hz to 20 kilohertz. That is our audible range or sonic range. But this is the least minimum level of loudness which the human ear can perceive. So we will discuss the rest of the two characteristic property in the next session. Thank you.